All right, welcome. Thanks, everyone. It's Education 24. So we can first hear any thoughts people have. Then we have a few topics we can return to in Shingai's work, in our joint work with XML, and with Gary's works and anything else. So we'll just start with it open and then could go to the to Gary's education topic, or however people prefer.
I really don't mind.
Yeah, just start it off with where we're at, or what is happening here.
Okay, so we had the educational event yesterday, which was supported by the SciSTEAM initiative from INCOSE. Christopher Chase gave a short talk at the beginning, and then Caitlin Singham, who is the director for the INCOSE SciSTEAM initiative, and then I gave a short talk on the integration of system science. We had, I think, about 23 different educators attend. Uh, both Jen and Daniel were there. I think Jen took a screenshot of the attendees. I've not seen that yet. We did record the talks. We didn't record the roundtable that occurred afterwards. We have some ideas in terms of how we're going to work with SciSTEAM and make use of their current logistics. There are a number of different ideas which came forth. So one is to put together a paper, basically putting together essentially a position statement on candidate laws for systems. There was also the idea to collaboratively work together on training material or education material for basically school children, and there was also seeing the need that we do need to have a foundational core that we can all refer to. So it was basically a scene setting event, really, to find out people's levels of interest, and to find out what they thought success would look like. I think it was a useful event, but we still need to follow up with Caitlin and Daniel, and work out exactly what our goals should be, and how we're going to go about it. But there's certainly a lot of interest shown. Um, Jen, Daniel, anything to add from your perspectives?
I can add a couple thoughts. One of the things that was apparent is that the enthusiasm and interest for systems education, at least at that table, means to me that there's a possibility that the deliverables or the interests in contributing could expand beyond the core, which was the reason why we all gathered. And so recognizing that there could be some scope creep, and then there's an importance to stay connected with this committee, with Daniel as VP Education, just to make sure that we don't discourage people from contributing to systems education, and that we find opportunities for everyone to contribute where and when they feel like they want to, even if it's different than the core, the system science core.
Yeah, that was a view that was shared by Caitlin as well.
Yeah, well, I only knew you all in that discussion. in the roundtable, just to the second part first, it reminded me a lot of like the earliest phase of what we did here with like, well, there's K through 12 education, and then there's like research consilience and synthesis, and then there's indexing materials, and then there's language translation accessibility, and then there's bringing art into the picture. It's like, so having those slots with, of course, the always trade-off with like not over systematizing and not over operationalizing for other reasons, but like understanding what those lanes or those buckets are, recognizing that they're going to change, but knowing where they are so that people can get up to speed on what's been happening in a given area, and kind of have that like meta team awareness with like, where are we at with bringing our different works together. And then especially because it is interorganizational, I the email that was sent from the ISSS team representative was very comprehensive, and also pointed towards like the need to have a clear MOU, something that the education committee can print up on the wall, refer to, evaluate decisions based upon their scope as that committee, and then within that relationship with the MOU and the mission and vision statement for what this core is. Of course, we see possible synergy and positive, especially over deep time with like between the research synthesis work, what are the candidate laws, if and then of course the meta is laws, even an appropriate way to think about it, and so on, and the younger, but how to keep these different aspects engaged, I think the committee can do. And then this MOU is like our portal or edge into this other project that's not simply at the ISSS. So just understanding like, what about ISSS are we leaving behind when we go into this other space? What are they going to be expecting us to be doing? And then how are we going to keep this manageable and aligned from our side, being like on the board of directors or being volunteers on these projects, and then how to make this, what happens in this shared endeavor, something that's like bigger and better and different than merely like a prosthesis of one of the organizations.
Yeah. Well, we have the draft MOU. Caitlin has made some additional changes to it because so the existing MOU with Incosi basically has some statements which make it which clarify the situation on ownership of products. Yeah. And the SciSteam initiative, although it is sponsored by Incosi, everything that's being created is going to be Creative Commons. So it won't have an organizational owner. And Caitlin wanted to make sure that was taken into account in the MOU. So Caitlin has added some commercial aspects in that, which both Jen and as the signature for the document, and also Incosi will need to be comfortable with. So some of the things that Caitlin has put in will be new to Incosi as well. But I think that what's in there is pretty good. It describes the relationship well between the education committee and the the SciSTEAM initiative, as a
Well, just to
cooperative
clarify
effort.
there, you see the intellectual property, or it is the case that the intellectual property is open source with the allowance for commercial activity, with permission or without permission, or it simply is open access. It's Creative Commons. Anyone can do anything they want, including commercialize it and change derivatives and so on.
As long as, well, I believe that's the case with Creative Commons. It can be commercialized, but you have to make reference to it. Is that the case?
I mean, there's the different flavors of Creative Commons. So just which one we exactly pick, whether somebody has to ask before doing this or that, but that is, I think, on the right track. But you see it as basically somebody being able to make a commercial product using it with attribution.
Yes, I mean, the whole idea of the Common Core, for instance, is that everyone would refer to it in their education material, but they would differentiate around it, for their particular audience.
Yeah. And
Yeah.
are there going to be other parties or other MOU? Because since it's so multilateral, we want to make sure that like there are commitments to an approach and a process and a timeline. On our side, some of that can be done with the education committee, where somebody can agree, for like a 5-year stint or whatever it is. However, how will we know that people are going to be doing like anything, let alone just being nominally listed or even being like kind of in some current future point, like not aligned?
I'm not really sure I follow what you mean, Daniel.
Like this MOU is between
ISSS and
ISSS and
ISSS,
INCOSE.
yeah.
And
So
then there's 21 other sides.
yes,
Do they have MOU with the project, or is it only going to be bilateral MOU?
it's a bilateral MOU between INCOSE and the ISSS, and it also states in the MOU that this does not prohibit us creating MOUs with other parties.
Okay, so the project is anchored in a bilateral relationship between ISSS and INCOSE, or is it anchored in a more multilateral base layer?
No, it's bilateral.
Okay.
Yeah.
Other, I just speculatively, other individuals would want to probably know that, and also whatever it's called will want to know what their expectations and preferences are for
Yeah,
being involved.
so I had a conversation with a couple of the professional educators, and if we were to, for instance, create a common core, the copyright for that would actually be secured in a paper, where all of the people who contributed would be co-authors.
I mean, it's an approach I'm familiar with doing multi-author Creative Commons publishing, generating either on the more research synthesis consilience side, something that at least has to be comparable to a textbook / George's textbook, in it to be comprehensive enough to be useful, more useful than other resources on the research and synthesis side, and develop the curriculum, especially if people want to really think broadly about like developing like a semantic crystal of a curriculum that we can then make into multimedia in different languages. Like it's hard to just have a shared document and co-author a paper, because we're not just doing some form or rote process and then just kind of like all stamping a seal of approval. Writing a paper is very non-trivial. I think we could facilitate it, and the right inner team of people, and then a commenter and co-author sphere could. And I guess this project would provide that organizing opportunity.
Yeah.
What is the name of this project?
Well, it would be towards a common core for systems education.
It's called Towards a Common Core.
Towards a common core for systems education.
And it's basically a joint endeavor based upon an MOU between INCOSE and ISSS that we open up broadly for all the reasons. But it's massively participatory, in fact, and it's grounded in this MOU, primary MOU, and then we'll have secondary ways of, with different stakeholders, like what they expect and prefer.
Yeah. So I'm not expecting that we will. I mean, we may set up additional MOUs with professional education bodies, for instance, but not sure if we would need that. I think we have that as an option if we want to formalize the relationship.
Like if someone outside of INCOSE or ISSS, or for that matter, actually somebody even within with that membership, if they're like, I want to participate in this project, but I want us to have a terms of understanding, and we can give a kind of we can have basic common features like your participation's open source, etc. But then we may want to have a bilateral relationship so that we know what we can actually rely on people on, or however you see.
Mm.
And then what are the next things
So
that you will be
so
doing?
Size Team, for instance, not all of the members who are participating in Size Team are actually members of INCOSE. That's the way Size Team has been set up. So people who are participating, as individuals or representatives of organizations, like universities, for instance. But everything that they're doing is all done under Creative Commons.
So what are the next stages here?
Well, the first thing that we need to do is we need to. So Jen needs to read through the changes on the MOU that Caitlin has suggested, and then we will need to get back to INCOSE with our proposal. The MOU that we currently have is due to expire in September, so we want to get this out to INCOSE within the next few days.
Okay, then with the MOU, what would we do?
Well, the MOU would be signed by the INCOSE president and Jen McCarr as the VP admin and CEO.
And then we do what in terms of synchronous or asynchronous activity?
Well, that's something that still needs to be discussed with Caitlin. So they have an existing Discord server and set of channels now, and I think it would be a good place for us to collaborate. The SciSTEAM initiative has bi-monthly meetings as well, and we could again participate in that and use that as a common area of collaboration.
Okay. So the
So the
MOU
size-
is between ISSS and INCOZ, but they
Yes,
kind of have their size team. We kind of have our
yeah,
education committee,
that's
and then
right.
these are the real collaborators, but the organizations are just saying, yeah, this is how it's happening.
Yes, yeah, yeah. So the two initiatives are organizationally separate in terms of, one is owned by INCOSI, one is owned by the ISSS, but there's a mutualism between the two. Essentially, and this is described in the MOU, we take the lead on, let's say, the theoretical foundations, and SciSTEAM take the lead on the practical application.
George or Shingai or Jen or anyone? Peter?
Yeah, nothing major on my end. I would just say yeah, I'd be curious what documents, PDFs, presentations I could take a look at in order to really get a sense of what SysTeam is focused on. And yeah.
Caitlin did a 20-minute talk on the SysTeam initiative as part of the event, which was recorded. The presentations at the beginning were all recorded. So they're up on YouTube now, so I can share the link with that.
Okay.
Yeah, you could
I'll
just
do
put it
that
like,
now.
yeah,
I'll put it in the
I'll
chat
make
now.
a full page. Yeah, or you can just add it directly and improve directly these pages, like with what information to onboard towards a common core.
Yeah. So Caitlin was also talking about essentially putting in place a common document. What's the term for it? It's essentially it's almost like a project charter, if you like, yeah, to describe the scope and the contributions, that kind of stuff. So that's something that we'll work on, and I think that this group here could help to put that together.
Sure. Cool. Okay. Okay. Next topic could be Shingai, if you want to share about this work.
Yep, absolutely. And there's a small chance I may have to let someone in at the door within the next 20 minutes or something. So maybe interrupted briefly. But so this is a systems analysis of Bitcoin that I'm working on, inspired by the work in George's book, really trying to apply his framework for understanding systems to a system that I'm familiar with. So it's a bit long, so I'm going to kind of skim through it, but try and cover all of the major components. Can I share my screen, Daniel?
Yeah.
Awesome. And yeah, I think that this could turn into really great educational material in the future in terms of giving people a sense of what it looks like to do rigorous systems analysis. So the inspiration for this, Bitcoin is the original blockchain. It's the open source technology which spawned the entire field of blockchain-based technology. And since this technology is being adopted at a very rapid pace, a deep understanding of how blockchains work is important to ensure that we integrate them into society in a healthy way. So a deep systems analysis of Bitcoin will help us understand why it gained early traction, what factors have acted as barriers to adoption, what issues might prove problematic for its future survival, and why it has struggled to fulfill its stated purpose. Bitcoin is a relatively simple blockchain with over decades worth of historical data that can be used for analysis. And I think that simplicity and large data sets will be useful qualities as we're testing and developing this novel process for systems analysis. The analysis can provide useful context that will inform future analysis of other more complex blockchain technologies. Does all that sound good and make sense? Yeah, okay, great. So the first stage of this process is identifying system of interest. The key questions that we are wanting to answer are, what is the purpose of the system? How does it do what it does? And does it do it well enough? Since the objective of a deep analysis is to answer questions about purpose, function, and performance, we start our analysis at the output of the end system. So we can refer to the technical Bitcoin white paper, which outlines the vision for a system for electronic transitions without relying on trust, a purely peer-to-peer version of electronic cash, and more technically, a peer-to-peer network which uses proof of work to record a public history of transactions that becomes computationally impractical for an attacker to change if honest nodes control a majority of CPU power. And we're just going to call this a blockchain. That is what the system is designed to produce. So yeah, the output is a blockchain. We start by filling in the details of this equation 4.1 from the textbook, which is a definition of a system. We're going to be defining the system of interest at level 0. So if we look at this right here, this is the SOI at level 0. At this point, C, N, and T are empty sets, and this delta T variable has to be estimated, and this will guide the selection of sampling rates to be used in measuring input and output flows. So yeah, next step is to create the product flow and terminals objects. So the product is any output that is actively accepted or sought by a customer. So what Bitcoin produces is a blockchain, and we could also view the cryptocurrency, the digital token Bitcoin, as another product, but I'm not going to focus on that. And the convention is to refer to Bitcoin, the network, with a capital B, and Bitcoin, the cryptocurrency, as a small b. And we're going to be focusing on the big B Bitcoin. So we have a system of interest, which there's an interface on the boundary, and the customer interacts with the product through the interface. So we're going to be filling in this interface element, this product flow element, and this customer sync object. The interface is a subsystem of the system of interest, which is responsible for managing the transport of the product across the boundary and the transfer of such to the appropriate customer. So one main interface that I identified for Bitcoin is the graphical user interface. This is the software that a user would download in order to interact directly with the Bitcoin blockchain. In the early days, this is like what it was all about, was using peer-to-peer transactions. There wasn't really much about currency trading and speculation and investment. These days, most people don't actually download the software, but in the early days, yeah, this interface was like the primary means of interacting with Bitcoin and just sending transactions back and forth. And so we have this table that will be a part of the system's knowledge base, which has elements and then the data associated with it. So we have this interface object, interface at level 0, interface 1. It's called a wallet. It exports the blockchain from the system of interest, and I'm classifying its output as a message. I don't know if that's completely accurate, but that's what I'm going with for now. Other potential interfaces we could look at would be the GitHub repository, which is where developers interact with the blockchain. We could look at exchanges where people trade their fiat currency for crypto. And we could look at blockchain explorers, which allow people to examine all activity on the blockchain. Next is the product flow object. So this would be the blockchain. So we can look at every transaction. The transactions are batched into blocks. And so this is the this is the main product, is the blockchain. It's exported to customer Y. One important parameter that I identified was the number of transactions per unit of time. So Bitcoin averages about 5 transactions per second. Some other relevant parameters we could look at might be the size of the blockchain, growth in megabytes per unit of time, number of wallets created, etc. And then finally, we have the customer sync object. IEEE published a paper a few years back about who uses Bitcoin, who are the users. And so this is the sync object. They are receiving the blockchain. They are a user who holds a cryptographic private key. And another potential customer might be a blockchain analyst who's inspecting the blockchain for insights. I used an open source program called TLDraw. It's basically an open source version of something like Lucidchart in order to create a diagram. So we have our system of interest, we have a wallet as the interface, we have the blockchain, which flows to the user, who is the sync. And something that's really cool about this software is it lets you export the file as JSON. So this is a way in which we could sort of start binding the graphical depiction of a system into the programmatic back code. So this is the JSON, which describes the visual image that I drew. And so some questions I have for George and anyone else are, am I starting on a solid foundation? Are there any fundamental assumptions I'm making that should be reconsidered, or any major issues with how I'm framing the analysis? And also, how would you think about applying the complex adaptive system archetypes, the agent, the governance, and the economy archetypes to Bitcoin? And that was it. Sorry if it was a bit rushed, but trying to be conscious of time.
Wow. It's really thrilling to see some ideas actually being used.
Yeah, I had a lot of fun doing this. I think it has taken a while for all the ideas to percolate and to be able to get to this point, but I'm having a good time. It's a fun process.
Oh, that's great. Yeah, you'll get in, you'll develop a pace that and a lot of this will become pretty automatic. I think that's a very good question about the use of the archetype, because I presume that this is certainly an adaptive system, but also probably an evolvable system. If it's open source coding and people are constantly updating it or doing something, on the GitHub, then that would be a place where you would identify the evolvability. Let's see, there were gosh, I can't. I had an idea while you were talking, and I've lost it now. Maybe when I go back through what you've done, I can recapture what I was thinking at the time. But
I'll just add a few points. Well, yeah, it's awesome to see. The big question in terms of the solid foundation what is the audience in question and intention? For example, here you're abstracting over the proof of work mechanism or of cryptography or of like the bioenergetics. But of course, this is a key differentiator of Bitcoin and understanding its interfaces with peers and with other systems is not only interfacing through the API type interactions with the blockchain. So this is very much described like a data science or a computer engineer's view, with abstraction over the physicality. But in general, taking this approach and already seeing where the sys XML could weave through, like, we know that we're going to introduce these 10 variables, and they're in these 3 different categories. So we're going to structure the introduction and the educational material according to these 3 categories. We're going to introduce what's necessary and sufficient, build up the equations bit by bit. Very cool. And then, of course, if that has continuity with the descriptions, with the analytical equations, the natural language descriptions, the graphical representations, and then the clincher is the executable simulation.
Yeah, absolutely. And when I was talking with Orion, who's a block science engineer working on building out their knowledge-based infrastructure, I asked him about the feasibility of connecting this mathematical framework with CAD/CAD. And I was like, is there any fundamental reason why, you couldn't make that translation happen? And he said, no, it's simply a matter of adding the right constraints. And so when I look at CAD/CAD and its focus on modeling dynamical systems, it seems like what we need to do is figure out which parameters in the knowledge base we want to map directly into CAD/CAD. And most of those parameters have to do with state. So things like, transactions per second, that sort of thing. So one thing I'm thinking about is, like, which knowledge-based parameters do we want to focus on sort of exporting into CAD/CAD? And I think it's parameters that are relevant to dynamics.
Yeah, there's a lot of CAD/CAD inside baseball. We could explore Ocean Guy whenever you want to. We can, but that makes me think about how we want to have the intrinsic coherence view from the inside, where using reference identifiers, which is like what they use at block science or some other technique, we have a descriptive wrapper around like block 4, actual Bitcoin block 4. We've pulled back to the category theory. We understand Bitcoin block 4 as being part of a kind that we're going to call blocks. So we have an internal grammar by which it makes sense, which in the case of Bitcoin, which is why it's such an important study system, because it's fully open source and we understand basically a lot further layers. And then, so then that is where there's the mempool and the transactions per this and that, and then the open-ended Bitcoin as system interfacing out. Then you could have a mimetic system of interest connecting to it, or you could have all these different, but then that goes outside of Bitcoin. But you can show and iterate and show the whole journey too, where like you entered in with a system of interest at that moment was Bitcoin. And then once we had Bitcoin sysxml v1, started on 0.01 for Ethereum. And then with those 2 in hand, it was easy to transpose into this. And the state space, once the state space of blockchains or even cyber physical systems was mapped out, it got faster and faster to map in new blockchains. And then there was a new open question, which was interfacing the blockchain with this.
Yeah, absolutely.
Yeah, fun. and just showing how much the word systems is used near Bitcoin.
Mm.
It's probably just used absolutely pervasively.
Oh. Yeah. Yeah.
And then just the way that somebody describes it or used that, like if they think of it as an economic system or a computer system or
Mhm.
identity system, then use that as the entry point to broaden the system's view.
Mm. Yeah, absolutely. It's 12 times in the white paper system.
Which means it has all the properties of systemness. So even if Satoshi's paper wasn't the system science textbook, of course, but you know, each chemistry publication isn't the chemistry textbook. So Satoshi didn't need to make the big, I mean, it just this stuff goes without saying. It was a different genre, but by invoking systems and systemness, that is the approach, and that's what we're studying. Now I'm just chopping up the notes so we have a little more clean.
Yep, and this document is it's public, and I'll leave it public, so anyone's free to look at it. Maybe I can enable comments as well.
Cool. Well, in our last okay, now. Good. Little shorter now. In our last 10 minutes, anybody want to talk about anything?
I don't have anything more pressing.
Okay. So let's kind of then take a little stock of what we have in education. Also, for those who like to play around, previously in the language modeling, we were doing it in the tables. Now at the bottom right, now there's a direct page scale language model capacity, which is just the gateway, of course, to document and multi-document capacity. Good multilingual. Still, it's pretty fragmented, using Perplexity for a few things, using API for a few things, Code AI for a few things, but these will come together more. And groups that want to make this a part of their ways of working already can. But in terms of ongoing projects, we have the sort of sysxml research we have two kind of ISSS type public front interfaces. The education did the system census. I don't look at this or maintain it anymore. Let's see. We haven't gotten any more submissions in months. Haven't tried, but it's there. Then we have the public interface for the knowledge engineering, which is currently at the bibliographic level of detail for all ISSS collections. And Rob is continuing to develop the SCA. We have Shingai's newsletter and adventures. And then now we have Towards the Common Core, at least just as a place that we can revisit weekly.
I might add in there, if I could, systems literacy.
Okay. How do you want to check in on that or interface with it here?
Well, it's been a topic of some conversation in ISSS since 2015. So even just assembling everything that's gone on is on my sort of 2023 to 24 agenda. And I mean, Lynn Rasmussen and I have been working on what she calls a field guide. I mean, it's her field guide, which came out of the 2018 ISSS conference as an idea, and she's developed it in her own way. And as time permits, I want to continue to develop the idea of a systems literacy initiative.
Cool. Whenever you I mean, you can email or send materials or put them in this page, but we can definitely return to it as we just on this pace.
Yep.
Okay, the bylaws have been modified. So I'm going to just change this to say from the old ISSS bylaws. But the paragraph that you just pasted in there is still in effect.
Yeah, so that was taken from the old bylaws, and it's been put into the draft for the policies and procedures, which is being worked on at the moment. So, you know, that is the status quo in terms of what is expected of the Education Programs and Materials Committee. Yeah, so you know, if we are going to be having something like systems literacy, then it should be under the governance of that particular committee. You know, as should the work that we're doing on the Common Core. Yeah, if we're going to provide a statement on foundational laws for systems, you know, as a means of education, that should come under that as well. So all of these things need to be integrated in some way.
Well, we're always out here firing flares and looking for people who want to see how we laid out together the scopes. And people are always welcome to develop and version and improve it in this space and or merge it with their own spaces. But I think it's continues to be hopefully useful to have the open meeting place. And whenever this is going to be actually brought into play, then let's figure out who's the other chairperson and who's going to be on the committee. The president appoints them, so it's not simply even a volunteer committee then.
Well, that's going to be a problem.
But this is it's being moved from the bylaws where it was potentially inappropriate to so then it is not so binding, but at least that's how it was written.
Yeah.
Obviously, yeah.
No, if that were to end up in the policies and procedures as is, I mean, my experience was pulling hen's teeth to get anybody interested in serving on any committee for that matter. So I'm not sure why that was in there in the first place, because it's an all volunteer organization to begin with. And I just don't, and also the last line there, it says the chairperson shall be elected by the committee. And I just said that the VP Education is a co-chairperson.
Yeah, they must mean the other, they must mean the other co-chairperson. But I mean, hopefully before it is even brought into policies and procedures, let us all discuss it again so that it's like appropriately participatory and supports what we already do and what we want to do.
Yeah.
It doesn't, we're not even bound to, I mean, we're not bound to the name or the timeline. This is not, this is just our starting hand.
Yeah. Yeah. I mean, this is the advantage of taking this was the whole point of taking the policies and procedures out of the bylaws, such that we can now actually be much more flexible about, you know, our internal governance. Yeah. Because previously this was all in the bylaws, and in order to change it, we'd actually have to change, you know, that legal document. We don't have to do that anymore. Yeah. But I think the intent is the intent from the, you know, from the founders, I think was very interesting, because by setting up committees in this way, which includes those externals, you know, we're actually doing, you know, what we need to do to make the ISSS vital in terms of ensuring that our customers are actually part of these committees. Similar with the publications committee. The publications committee is actually made up of editors from journals, you know, that are systems orientated. So these committee members don't necessarily have to be ISSS members.
Thank you, Jen. Any other comments?
None here.
Cool. Also, just for the fun and the history of it all, today is kind of our internal timelines for this grant solicitation for the Active Inference Institute for post grant at the NSF. And there's a phase 1 and there's a phase 2. We went for phase 2. However, phase 1, like from the peer projects that I've seen in the phase 1, various of these efforts with an appropriately motivated core could absolutely be cast within an open source ecosystem setting. I don't know what the probability is of you know, getting it, not saying the risk reward, blah blah blah, but like for those who want their work to be part of an open source ecosystem, go to where that is happening. All right. Okay, well, at the end of August. Okay.
Thank you.
Anything else? All right. Thank you, everybody. Farewell. Bye.
Bye-bye.